Right. Hello, everyone. Let's get started with ITS 530. So we're going to go here. Okay. So just a couple of things. I did set up the Scholar thing. So by tomorrow, I think they will have created the accounts. And that's for... Yes.
Checking to make sure.
Yeah, I think so.
I guess.
Well, okay. So far.
Okay. I'm not going home. So if you need, I'll know.
Oh, okay. Yeah, so I got the Scholar set up for you guys. So for those of you that don't have the GPU boxes, hopefully remember you might be able to use that for your homework assignments. Okay. If you have your own GPU boxes, then you're in luck. All right. And also there's CPU option there as well. All right. So at some point tomorrow, I think overnight they'll somehow you'll be able to log in there. And that, as I said, you may not need to use that resource if you have your, own resources, but that's definitely something that we have available. And they'll give me some material or something so I can provide, the links, etc. Okay. All right. So we're gonna get started today. So last week was week 1, right? And I just gave, what this course is about. So today we're actually going to get into the material, and I'll go over some of the ideas. So if you, as I said, mainly this course will have like, NLP, which is where we're starting, dealing with language, large language models. And then it'll be like 1/3 of the class maybe, or maybe half of it. And then the other thirds or half will be images, fast AI, and also a few topics that are important and don't really have a place, like reinforcement learning, which is important for a lot of things these days. Okay. So this is basically the sequence that I'm following. So today we are starting with this module, HuggingFace transformers. So basically this is where you want to start, in an applied deep learning course, because here, we want to leverage the power of transfer learning, right? So as I stated, that's really the main, element of the class, the main assumption that we're using transfer learning as much as possible. All right, so I kind of gave an idea of fine-tuning and pre-trained models in the first lecture. Today, I'll just keep talking about that. So kind of this week, today, basically, we're going to do a lot of examples of HuggingFace transformers, right? So I've explained to you, that's basically just code wrapping. So, a nice company, they've taken models, right? And then people share them on their hub, right? And you can download them, upload new models, fine-tune them, do all kinds of things. So basically, my plan is that you'll have 2 homework assignments in this topic. The first one will be the, where is it? Yeah, the transformer here. So basically, we're going to take a GPT from scratch and you're going to train it. So I'll discuss some of that. And then the other one is a challenging one. Well, in both you need GPUs. Unfortunately, one in 20 minutes or so, depending on how big your stories are, you'd be able to train your model. The other one might take 2 hours on a GPU. Okay, so, but both assignments I think are pretty good. And that's kind of what, basically you'll just be working on that. Okay. And I provide the code obviously, but you still need to do some hard parts like dealing with the data, right? So that's the nice thing about something like HuggingFace is you get a lot of pipelines, right? But you still, if you have your own problem, your own data, you got to fit that data in there. And that's really the challenge. Okay. So the way that I'm thinking about this project is that each of you would have a different data set, right? For both examples. So I think I mentioned a little bit of this last week with this idea, this topic of RLHF. It's a big topic, so I'll be coming, it's kind of like a common theme. Every week I'll talk a little bit about it, right? Because it's like like a really big thing. And then after that, we'll just talk about this is the Vaswani paper. So this is the original transformer. So everything in NLP today is transformers. Okay, transformers really have replaced everything. and they become a very powerful tool. So this is the original Vaswani paper. And basically, we're also going to talk about BERT models and GPT models, right? So those are the three underlying things. So a transformer, I stated this before, is made of encoders and decoders, right? And so by next week, I'll have those materials ready. Okay, I'm still writing out that whole transformers, BERTs, and GPTs, but I should have it ready by next week. And so that's kind of us getting into the algorithms, right? So, try to understand how it works. But in general, you'll be using something like HuggingFace usually. At least you'll start with HuggingFace. You'll start to do a bit of the pipeline and then maybe get into the details if you have a very specific project that's different. Okay, so we'll talk about that. All right, so today the basic idea, I want to start with this module, HuggingFace transformers. I provided all the links, and so we're just going to implement the code, and I'm going to discuss kind of how it works. It gives you a feeling of how HuggingFace works. I think we've done one already, right? We did the Hello World GPT-2 example last week, so you've done that. Hopefully, you were able to run that at your own in a lab or in your laptops. And today we're just going to continue. Most of these are going to be BERT models. Okay, so remember, transformers have encoder and decoder. Encoder-based transformers are just BERT models. Decoder are GPT models. Okay, so we're going to do that. So I think we created an environment. Did we? Yeah, we created an environment, right? Okay, so then I'm just going to open the environment here. Anaconda, right? And Anaconda prompt. Okay. And then I'm going to go to the desktop where I have these files. Right, so this is the Hello World example that we did last week. I already loaded this to the GitHub, so you can get it from there if you don't have it yet. All right, so now let me click on, so I'm not going to type this up, right? So I'm just going to copy kind of the code from my own GitHub, and then I'm just going to go over how it works. So so it should be this module. So the link is provided here. So click on code. And that should open basically in the transfer learning repo under HuggingFace transformers intro, basically. So here today is just really like a whole bunch of examples of how to use these models, kind of talk about what's going on. At the end of the day, they're just deep neural networks, right? They're deep, transformers are deep neural networks. In the end, they already have weights, right? They've been trained with a lot of data. So the weights are really good. And then they can perform certain tasks, okay? And so we'll talk about how that works later. But today we're just using transformers with weights. And through HuggingFace, we can actually already do specific tasks, okay? And that's kind of what we're going to look at. All right, so I will start the Jupyter here. So let me do conda environment list. All right, and I'm going to do conda activate.
The HF1.
The HF1, is that the one? Okay, yeah. Pi 37, ITS 530, HuggingFace. Okay. All right. So yeah, that should be the one. I think it has all the libraries, and I believe we did install all those things in class. Okay. So now let's, we're in the folder, and we have our active environment with the HuggingFace transformers. So now let's go ahead and start the Jupyter Notebook. All right, so I was already doing this today, practicing them. All right, but I'm going to start a new Jupyter here. Okay, so I'm going to add a few cells. I'm going to rename this in class. Intro HuggingFace. Okay. And these are basically mostly BERT models. So rename. All right, so let's look at what we have here. So I think, as I mentioned to you, basically, people in AI are funny people. And so they started this joke of calling one Elmo, I think, and then the next one then was called BERT, right? So it comes from Sesame Street, right? And then from there, Roberta, Albert. So you can see Albert. There's the Stillbert, and so many variations of it, right? And you can use them for lots of things. So I'll show later how you can use it for a really nice application. But here, let's just start looking at the basics, okay? And I think I kind of just showed you on the repo what it did, but we're going to run it in class just to make sure all the libraries are available. And then as you start to look at these models, you might start to wonder, how do they work exactly? Now, keep in mind, as I've said before, this is going to fill up your computer really quickly. A lot of these models the small ones are 1 gig, the small one, okay? So just watch out for that. All right, so we're going to need some libraries probably. I've already installed these sentence piece, torch and pandas. Okay, so if that gives you an error, these are the commands. I'm going to just copy them here. And you can run them. Let me know if you have any questions about running them or getting the environment set up. Okay. All right, so let's go ahead and think of how HuggingFace works, basically. So HuggingFace has this library called transformers, right? So it's got from transformers, and then usually when you're dealing with a transformer, whether it's a GPT or a encoder decoder or it's a BERT model, you need 2 things that are separate items that you bring in. The model itself and then the tokenizer associated with that. And the tokenizer is just basically like a dictionary, okay, where you have words or syllables or letters, whatever it is, and the associated ID with it. Remember that a transformer cannot take strings into its neural network. It can only take numbers, right? So that needs to happen there. All right, so here from transformers, we import Albert tokenizer and Albert model. They usually have variations for every specific one, just to be more, because the thing is, here's what's different. BERT is, like just an encoder as was published in the Vaswani paper. But then Roberta might have a tweak here and there. They made something bigger or smaller, maybe they usually don't add new layers, but they just may have changed some of the parameters. And so when you do transfer learning from one model to another, so one person to another person, 2 things need to be consistent. One thing needs to be consistent, and that's the architecture. So whatever architecture is in one model needs to be in the other one so that the weights can fit into it perfectly. Otherwise, you won't be able to get the weights in. Okay, so that needs to happen. And so that's why they specifically write things like Albert. So that tells you, okay, that's that paper when, by Google or something with that architecture. And then you can move the weights in there. Okay, you could do this on your own. Like you could load weights and in PyTorch itself. HuggingFace is just using PyTorch or TensorFlow in the underlying code. And like I said, they're just doing code wrapping, but it makes it a lot easier to work. It's more robust also, like things actually work or things are not like hacky and breaking all the time. All right, and then they have this other construct that's really nice called a pipeline. And the pipeline is a way of taking a model and also saying, okay, I'm going to use this model, but for a specific task. So you can imagine, like, you know, has Albert ever been done for sentiment analysis? And if it has, then it's in the pipeline in there. And all you have to do is say, okay, use an Albert model for sentiment analysis, and boom, you have a sentiment analysis pre-trained model, maybe even fine-tune. All right, so today we're not going to be doing any pre-training or fine-tuning, right? All we're doing is what is called inference, okay? So that means that we are just predicting, right? That's all we're doing. This is why we can do this, you know, in reasonable time, okay? Because we're just doing inference. But if we were doing fine-tuning and pre-training, which is actually what you will do for your homework assignments or your mini project, you know, then that takes time, right? And basically on a GPU, it's going to take from 20 minutes to 2 hours, you know, on one GPU. All right, so any questions so far? All right, so let's go ahead and run this cell. Okay, so remember it's thinking here with the solid. So we want to give it a minute. All right, so that's done. Okay, so now let's go ahead and actually bring in the model. So for me, this may be faster because I actually ran all of these this afternoon. And so the models are already there. It wasn't downloading on this computer for the first time. So all these things are usually cached by, you know, by transformers. So it's done pretty nicely. So I'll hit the run and you guys should hit the run. So mine finished already. As I said, I already have them. You get these warnings. That's just HuggingFace providing a lot of information. Not, you know, usually we're used to seeing a lot of deprecated things that are this pink screen, but in this case, they just provide a lot of details about how they did something. What's important here is notice you do Albert tokenizer and Albert model, and then you say from pre-train, and you go and say Albert base version 2. These are coming from the hub, from the HuggingFace hub, okay? So all of you can go today and create your own HuggingFace accounts. You know, I recommend you do that, right? So you can have your models there and share them. Sometimes these have like meta / and then the model. And they also have some that are just HuggingFace ones. So then, you know, they don't have a, you know, because, you know, they're their own models, basically. Another thing that might happen is you'll see this like Albert base, Albert large. So this is a common thing. So these large language models become really big really quickly. So they usually have a smaller version and they have a larger version, okay? And so usually I recommend just start with the base because the large will be, you know, pretty big. All right, and then they might have like versions. I've seen like a BERT IMDb. So that BERT model for IMDb was trained to create movie reviews. You know, so it'll want to review a movie or whatever prompt you give it, it'll want to review it as a movie in a sense. Okay, so there's a lot of this that's happening. Remember that all that happens is you have a neural net, a very deep neural net with special mechanisms, like something called the attention mechanism. And it's weights. It's weights. It learns how to predict text, you know, or various things like that. So we'll explore how GPTs and BERT models work probably next week. I'll start getting into the details of how they work. I'm not going to ask you, obviously, to code a BERT or a GPT from scratch. That would be a little crazy. That it's just not possible. But you're still, though, I'll give you this from scratch code, so you should understand how it works. Some of the major ideas. Those are the kinds of questions you can expect on the exam, for instance. Okay, but otherwise, we're just in general trying to use transfer learning. So we're trying to use these models to kind of do problems, solve solutions. And that's kind of what we'll do today. So we'll do a little bit of sentiment analysis. We'll do a bit of summarization. We'll do a bit of fill in the blank. We'll do a little bit of what is called one-shot classification. And just to kind of illustrate everything that's available, just, you know, just by running pre-trained models. Okay, so we ran these. So I'm going to hit it again. Okay, we're done with that part. So this is an Albert, which to me, it tells me it's a BERT. So I know immediately it's an encoder only. Okay, so I kind of have a sense of what it's going to do. So we can look at it here. Okay, so we can paste in. So the text is, the cat is so sad. Notice that the tokenizer takes the text. We tell it that to return PyTorch, because really the underlying deep learning library can be either TensorFlow or PyTorch. You know, HuggingFace has support for both, right? And you choose. I have a tendency to like PyTorch a little bit more, so my examples are usually in that. All right, then here's the model. It takes in the encoded input, as you can see here, right? And that should produce some output that we're going to show in a second. Okay, you can see this starts to show you information about the output of the model, basically the predictions, but it's all numbers, as you can see there. Okay, so we want to use the pipeline to tell it what to do exactly. So before, we just, we took a model here and we're just kind of using it like the information is correct, but it's almost like we need to decode, right? So you'll see when we do the GPT one, we'll do it from scratch just so you can see it. We're going to have a very simple encode and a very simple decode function. I probably went over this in 520 really quickly. I'll spend more time here, and obviously you'll get a homework of this one this time around. Okay, so we'll spend a little bit more time. All right, so let's go ahead and, oops, sorry, I skipped something here. Oh, sorry, yeah. Here, so I'm going to copy now pipeline. So pipeline, basically, for now, the way that you can think about this is you have a transformer, it gets integers, produces integers or numbers, real valued numbers, and then the pipeline may be adding a head. A head is the term that we're going to use when we're adding additional layers to a transformer. So this is another thing that happens in transfer learning. You might have architecture, let's say 10 layers as an example, but that's trained for a while, and then you add an 11th head, right? And now you freeze some of the heads. I think we covered that last week. And so the model gets trained, right? And only the weights of the last head are updated for the specific task. So you're effectively leveraging the pre-trained 10 previous layers, and then you have the 2 additional new layers. So usually the terminology for that is the head, a head. All right, so here we have the pipeline. Notice that we specify the model that we want. So this is an Albert base version 2. And the task in this particular case is fill mask or fill in the blank. So this is actually how BERT models were trained. All right, the original Google paper on BERT describes this procedure of how it was trained. Basically, the encoder would get the same sentence as input and output, but you would mask one of the words randomly, and then the transformer needed to predict that word. Okay, so this is the example here. It's native to itself. This is what it's really good at. So we invoke fill mask, the object, which is from this pipeline. The cat is so mask. Okay, and the mask here is a special token in the transformer that tells it, okay, I understand what's being asked of me. Basically, I need to fill in the mask. So we run the model. I'm going to hit save, run. So remember, it's doing inference, no training, pre-training, fine-tuning is happening here, just inference, basically. Inference is really important. It's not all, for instance, NVIDIA dominates the market for pre-training and for pre-training, right? Definitely, we all agree. For fine-tuning, you could use other processors, but still they probably dominate that market as well. But for inference, there's actually companies like Intel, of all people, or companies who think, okay, we're going to dominate in inference, okay? Because, they probably can't compete on the NVIDIA side, but they can compete in the inference side. Why? Because it's less resource intensive, right? So this is what we're doing right now, okay? So here is the result of using this. You can see that basically the pipeline itself for filling the mask gives us these options. And it tells us that the cat is so cute, the cat is so adorable, the cat is so happy, the cat is so funny, the cat is so affectionate. So if it learns how to predict the appropriate word for that task, okay? And then it gives us the score. These are the tokens. So that, remember, they're the IDs actually associated with these things, and then the token string. Any questions? That's the first BERT. You know, that's the first BERT. So we can do this for several things. So I was trying different ones. So we're gonna do this one, El Chapo. So I wanted to see if it thought that it was a horrible person, a criminal, or something like that, right? So what it knew about him. So I ran it, and basically what it's saying is mostly like it's a Spanish name, right? Because it's giving you things related to kind of Spanish culture. All right. Let's do a couple more. So let's do this one. Anna is a, and it says Anna is a wonderful person, is a funny person, is a good person. Anna is a lovely person. Anna is a nice person, right? And it gives us a score of what it thinks is the most likely thing. So it's filling in the mask, basically. Okay. Now let's look at Michael. It's going to say for Michael, Michael is a wonderful person. Michael is a good person. Michael is a funny person. Michael is a great person. Michael is a nice person. Michael is not a lovely person. Is that bias of the BERT model towards men? Huh? Well, actually, I say that as a joke, but this is a real important issue. This shows us that this model has learned to mimic humans. It's mimicking us, right? And it's, you know, and so bias, by definition, bias is in machine learning. Bias is actually how machine learning works. It's not a bad word in machine learning, but it translates into this thing where it does have these biases, these tendencies, okay? So we'll keep that in mind. Okay, so let's try this other one. All right, so here I wrote the nurse is examining the patient. Mask is writing down notes, okay? So let's take a look at what it does. What do you think about that? That's also bias. It's gender bias, right? And it's inherent in there. So it says, you know, the nurse is examining the patient. She is writing. You see how that's the first word that it shows. He is put lower in the prediction. So this is really important, okay? I think I've said this before. We're putting together, I guess, an ethics class in AI, and that's really important. What they say about AI, that it can actually have harmful things every now and then, is very true, right? Because very simple things like that do add that in, right? So the way that it's, you know, the assumptions that it's making, etc. Now, this comes from because maybe in the training data, it has seen this text, obviously, and this is what it concluded. But these are the things that we need to be aware of, and that's why there's a lot of research going on in something called debiasing, right? So it's a very important area. HuggingFace, if you go on there, you'll see they always have disclaimers and they have things, you know, and they try to, you know, clean up the models by debiasing them, etc. So there's a lot of research being done in that area. I was going to say somebody created a transformer based on a website called 4chan, which is a very toxic. This is true. Yannick Kilcher did this. I don't know if you guys have ever heard of him. He's a YouTuber, famous YouTuber, and he trained a transformer on 4chan. And a lot of people, like in the AI community, wrote a letter, and they were that he should take that down and everything. I think he did. He just said it was for research. It kind of freak people out a little bit, and he succeeded in that. But anyway, this is a very important thing, okay, guys? And so, you know, as you build AI models and you're using them, right, for things, you need to be aware of little things like that, you know, you may get excited that it's working for something else, but it can have some negative effect as well. Okay, so that's why I wanted to start with this example. Let's do one more. Okay, so I wrote this one. The doctor is examining the patient. Mask is writing down the notes, right? So let's take a look at this one. And you can see once again, now the difference is not that big here, which is good. So it's probably done some debiasing, but it's still selected here, right? So classic example of bias in large language models and the impact that they can have, especially with all these. I think ChatGPT or OpenAI now has an OpenAI store. Is this true? Imagine that. So they're selling all these products based on these models, right? So it's getting everywhere. And so it's an important thing to be aware of. Okay. All right. So that's this example. That's just using Albert, you know, a very simple BERT type model. Any questions, comments, thoughts? You want to strangle? All right. So yeah, so this is an example. We're going to move on to, you know, look at other models. I think I'll just continue in this Jupyter here, but you know, these are separate ones in the GitHub here. All right, so we have other ones. We have a BART model, which I believe it's more of a combination. So you can see BART, it's not a BERT exactly. So I believe this one is a little bit different. So you can read up on what it is. I haven't really looked into what it is. We also have an Electra. We have entailment. We'll take a look at this one. This is a really interesting one. We have Roberta. Roberta is a very powerful one. Roberta is, so again, there's this war, right, between like Google, Meta, which is Facebook, and basically nowadays Microsoft, which is OpenAI, or one is the other, right? So they're always competing against each other. And so obviously Google created BERT, so then Meta created Roberta. You know, Google or OpenAI created GPT 3.5, so Meta created Llama, right? So it's always like that. They have this rivalry. So Roberta is another paper of a BERT model. So they for the BERT, they said something, and then Roberta just kind of just made it a little bit bigger, I think. So they had it like more data, you know, and changed some of the inputs to be a little bit bigger. But in essence, a lot of these models have the same architecture, all right? If they're using an encoder, it's astonishing how they don't really change the architecture. They change a little bit here and there, but for the most part, they're very similar. So that's actually one nice thing, at least up until to this point. You know, the transformer was proposed in 2017. It is now 2023, and the architecture hardly ever changes. Like the ideas are always the same. So at least for, you know, for the end of this class, once you understand transformers, once you understand an encoder and a decoder, you'll know exactly how they work, because there's very, very small variations. And instead, what changes is the amount of data that's given to these models in general, the heads that they put at the end, things like that. All right, we'll look at some data sets and metrics. So I think I mentioned this last week, where I said that, you know, when you took 520, you learned that for regression, we use R-squared, and you learned that for classification, we use precision, recall, F measure, right? And we explain all those things. But what if you're doing summarization? Or what if you're doing language translation? How do you measure performance? So as it turns out, there's a lot of metrics for those things. So for language translation, there's one metric called the blue score, for instance. And so there are metrics, and a lot of these models are measured against those metrics. So, so when you're in the transfer learning world where you're doing a lot more difficult tasks, you will have new metrics. So that's going to be in this one, metrics and data sets. We'll take a look at that, the zero-shot classifier, and so on. Okay, so let's try another one. All right, so for me today, my goal is just to, like illustrate all of these so that you have a sense of what you can do. You already know what you can do with GPT-2, right? And as I said, you will use GPT-2 for your homework assignment, which I will. So I'll talk about the homework and the mini project right now, but they're not going to be due next week. Instead, what I want you guys to do is just start working on this stuff little by little. So I believe I set this on Tuesday. I don't do a term project in this course because we do, one part is like Fast AI, one is HuggingFace. So instead I do these mini projects. Okay. So, and we'll do 2 or 3, but no term project. All right. So let's take a look at BERT test. Let's see what this one does. Okay. So this one will do summarization. Okay. So let's grab, again, the libraries. I go over here. As I said, I'm just using the same Jupyter for this. Okay, so go ahead and run it. So, yep, done. So here, from transformers, we're invoking a module called AutoModel. We also invoke the pipeline. We're using the BERT tokenizer. Now notice they have BERT for conditional generation. When you see things like that, basically it means that you're using heads. It's, whenever you see that thing like for conditional generation, it's basically the underlying encoder, decoder, and then some additional layers, okay? Notice this BERT can generate text, okay? So it's a type of a GPT model as well. And you have a BERT config. So this is something that sometimes you will see because there's so many parameters, all right, that it just makes sense to create this one object that holds all the parameters in there. Okay, so I ran this library already. So now we're going to go ahead and follow the same approach. So I'm going to hit Control Copy, hit Enter here. All right, so notice here we use pipeline, but this time we're going to, we want to invoke here the pipeline summarization with a model and a tokenizer. Okay, so in this case, the model, you can see it here, BERT for conditional generation. Okay, so and this is another thing. So maybe you want another model. So the HuggingFace hub is a searchable place, so you can go there. They have a lot of things categorized, so you may be able to find, okay, I want summarization models. So you click on the summarization, and then it's going to list all the pre-trained and fine-tuned models that you can use for summarization. They usually have a little example of usage like this. So they'll say like import, and then pipeline and how it works. Not everyone does this because you could create your own and you just don't do it. Right, but in general, if you follow good practice, you'll create that little example of how you got it to work. Make sense? All right, so here then, notice the model BERT for token conditional generation. So from pre-train, notice this is somebody S. Schleifer, and then they have a distill BERT CNN 12.6. So these distill BERTs, it's common, distill BERT, etc. They're like smaller versions of the model. Okay, fewer parameters, etc. Okay. Then notice over here, you invoke BERT tokenizer, and the same thing, same model, but this is going to be the tokenizer. Remember the dictionary of IDs to words or subwords, etc. Okay. So now you invoke the pipeline and you tell it that you want a summarization with the model and tokenizer. Okay, so Okay, so thinking there. Is it? Yeah, I'm sorry. I did say this. I did say that. This class is gonna kill your hard drives. So delete them, and find how to get rid of them because yeah. Sorry. I don't really know what don't do it. I mean, I'll do it. I already did it. You don't have to follow along if you don't want. You can just look at the videos and then maybe do it for the homework, but at least for this one, I'm doing this. I mean, we won't every week we're not gonna do this, right? So it's just today. Oh, it finished, sorry. All right, so mine finished. So now so we have a summarization. Okay. Now this summarization may not be that good, right? So you may want a GPT-4, right, for a good summarization. And so these are just examples. They're already pretty big, but they may not be the best. So let's go ahead now. I have some text here. Okay. So hit run. So some aviation text. And then we're going to go over here. You can print it out. We don't need to print it out. And then you just run the NLP pipeline, right, with the text. And we go ahead and hit run. Okay. Oh, there it is. So it summarized the text. And it says aircraft includes fixed wing and rotary wing types, morphable wings, wingless lifting bodies, and lighter than aircraft, such as hot air balloons and airships. Aviation began in the 18th century with the development of the hot air balloon, an apparatus capable of atmospheric displacement through buoyancy. So it did summarize the text. You can try this with other things, go on Wikipedia, copy some text, and you can evaluate it, right? You can evaluate it. Now, what I like about this exercise is to talk about a competition, right? So let's say that there was a competition of all of you creating summarization models. You get some text and then you create the summarizations. How would we evaluate this? This is what I was talking about. So we're not going to use the R square, or we're not going to use precision recall F measure. Instead, there's got to be we have to have a metric for that, right? Because otherwise we would be stuck with just humans judging, and that's not apples to apples always, right? Everyone has their own perception of things. So instead, it's better to have like a metric. So this is a very common thing when it comes to transfer learning models. There are these metrics. You know that the metric is always consistent. So you would generate your summaries, and then the metric would look at your summaries and provide a score of some kind. Let's call it the glue score or something like that. And then whoever gets the highest on that, which is like the agreed score for that particular task, has the best model. And also you can fine tune models automatically just by looking at that score, because you can always adjust the weights, look at the glue and say, okay, it's low. I'm going to try something else. Okay, it's better. And that's a way of improving the models just by looking at these scores. Okay, does that make sense? So later in the examples, I'll show you like the list of scores, and I will provide a paper. There's a nice paper that describes a lot of these metrics, okay, as well. Any questions so far? Nope. All right. So let's continue. I think there's a sentiment analysis one, so we're going to do that one next. Pretty short. So sentiment analysis has been, at least in natural language processing, like a very common task that people spent a lot of time on. I wonder if it's this one. Can't remember. Nope, it's not this one. We'll do that one later. All right, so which one is it? Maybe it's Roberto. Nope. All right, we'll get to it. So let's just keep in order. So we did BART. Now I'm gonna go over this one. So this is what? Okay, so this is just a we don't have to run this one. This is similar to a previous one. This is BERT. So notice here from transformers, import BERT tokenizer, auto model and pipeline. So this uses BERT base on case. So this is one of the standard HuggingFace. Now you'll see this also. Case or uncase just basically means if it's case sensitive or not, right? So you might train where you look at case, or you might have a model that basically all the text was made lowercase. And so that's how it was trained. Okay, so here you can see you have the BERT tokenizer, you have a sentence, we can tokenize, right? The text, you can see it becomes basically integers. Like this, we'll do a simpler example where we write our own encoder and decoder a little later. Okay, so basically here it takes the text, you can print it out and look at it. We did this already in a previous example. And then here is just to fill in the mask pipeline with a BERT base on case, and then the man worked as a, and then you can see it says the man worked as a carpenter, a waiter, a barber, a mechanic, a salesman. Okay, so these are the more likely words that it's going to predict, basically. Okay, so that's another example. All right, let's take a look now at Electra. So Electra is, I know there's fill in the blank or mask. So we can just talk about this one. So as another example, you can see here from transformers, import Electra tokenizer, we import the pipeline. And then notice this is Google's. So we're going to import the tokenizer, Google Electra small generator, and then we create the pipeline basically for a fill in the mask. Okay, so now we can give it the input. The goat on the mountain will, and notice it says the goat on the mountain will die. Then the goat on the mountain will feed. The goat on the mountain will eat. B, the goat on the mountain will survive. So it's less likely to die than to survive, right? It's a very negative large language model. Okay, and then notice that from the tokenizer, you can look up certain things like the mask, and it's just going to give you the actual word that it uses. Yeah, please.
Can we specify, can we have more than just 4 cases? Is there a way?
There might be. I don't have that exact code, but it could be in the pipeline and fill in the mask specifying the length of the output. So whenever you have questions like that, I would definitely just say go to HuggingFace and look up pipeline. And they have very good documentation where they're going to say all the fields that it takes. So this is something that you will want to take a look at. So as I said, HuggingFace is very much a open source code. Everything is open source. They're not hiding anything. And they will have in there for all the functions, all the parameters that you can specify. And usually there's a lot. But yeah. So we could look at pipeline in HuggingFace. So I have the link here. HuggingFace transformers pipeline. Yeah, pipelines for inference. Right, so they have all the details. Use a pipeline for inference, right? So it gives you the specification of how it works, which is kind of what we're covering right now. They have really a lot of really good descriptions of everything. my parameter equal 1 here. Chunk length size 30. You can see how you start to see some of these fields, right? So that they do have that, you know, more functionality. So you just have to kind of look and specify the one that you want. If we click on, I think at the beginning they had a pipeline. You have to find the class definition of this. But yeah, so there's a lot of parameters usually actually, so, and you'll have to kind of search for them. All right, so I'll close this window, but definitely this is a really good resource that you can use. All right, so we looked at Electra. So let's take a look at another model. So we've done Electra. Now, oh, this is an interesting one, entailment. So this is like a model for predicting if something is, so you remember like in 520, right? We wanted to create our own deep neural network from scratch with MNIST data set or CIFAR 10 data set. So we would give it the images, we would give them the labels, we had to train it. As it turns out, these models are so good or at predicting things that they can also be used as classifiers. Like, you know, just grab it and try to use it as a classifier itself. All right, so this is what this example is about. So let's try this one. So I'm going to hit, this is the entailment one. So I'm going to go over here. Okay, so from transformers, we're going to import pipeline again. From transformers, auto model for sequence classification. So notice the head there, right? So they're basically taking, they're using these heads, these additional layers. So we're going to hit run. Okay, I'm going to go over here. This is, if you remember from 520, especially those with GPUs, you knew that you could change the devices CPU to GPU. So here is an example of doing that. All right, then we're going to have a couple of parameters. So we have a sequence. I'm going to France, that's the sentence. And then we have 3 labels. And basically the idea is this travel, cooking, or dancing, for instance, right? And so what this model is going to do is it's going to predict which one is the most likely, right? Based on the pipeline that it has and the type of model that you are downloading, okay? So this won't work well for everything, so it has to be certain models and etc. So here we're going to grab the models, and this is really a really important detail here. So if you look, we are basically doing the usual thing of, you know, grabbing the pre-trained models. We have the auto model for sequence classification. Again, you might see all these things and you're wondering, okay, how do I know which one to use? Well, remember, if you were doing summarization, go in HuggingFace and select summarization models. If you want entailment, look for that. If you want something that is going to tell me how to invest money in the stock market, that may not be available yet, right? So not every model is going to be there, okay? So, but they do have a lot of common models that are pretty good, and everything else you have to do. And then when you do it, you upload it to the hub, right? That's kind of the idea. All right, so and that's, you know, that'll be the project. We're going to talk about that during the second half of today, the mini project, so that you guys start working on this. Okay. So here, notice one important thing is we are down, this is a Facebook one or Meta, and notice it is a BERT model, which is is generative. It's a large one, so this, might be very big, and it's MNLI, right? So it's a specific naming convention that they've used for this kind of task that they're trying to achieve. All right, so mine runs quickly because I already ran these this afternoon. Yours might take a while if you're following along. All right, so now we've got the models, and so we're going to look at the procedure basically. So it's got this idea of a premise and a hypothesis, right? So this example is and it's going to try to predict one of the labels basically, given the sequence that is the premise. In this case, I am going to France, right? So it's trying to classify that sentence basically. So you can think of the example of IMDb, which is really simple. This movie is terrible. This movie is really great. So one is positive, one is negative, right? So similar idea. But this allows you the freedom of adding other classes there because these are words. That's the key thing that you're taking advantage of, that this transformer has learned association of certain words. So it might try to associate I am going and France with, okay, that's more likely to be travel. If I was writing my own sentence, like a prompt, I would say, I'm going to France for my trip, and I'm going to travel, something like that. And so depending on, it may be good or bad in this task, but that's the idea anyway. Okay. Obviously, as you improve it, it may eventually be able to tell you, oh yeah, that's travel. Does that make sense, guys? So the idea is that it's able to classify because it's able to predict words, like, given a prompt, basically. All right, so then, the premise, we know it's I'm going to France, so we don't need to print that one. We can print the hypothesis, right, which should be, okay, I did not do that. Did I not run this? Maybe. Okay, yeah. So the example is travel, cooking, dancing, right? So that's kind of what we're trying to do. And so now we can take the tokenizer. Let's take a look at the tokenizer. Run through the tokenizer here and code. Notice that this tokenizer is an auto tokenizer from BERT large MNLI. So it's a special type of a tokenizer that coincides with that, okay? So, that's important here. So then that tokenizer expects a premise, a hypothesis, and all of that. And so now when we run it, right, and we print X, you can see now you have the IDs basically, okay? So we'll cover this in detail. We covered a little bit of this in 520, if you remember, with letters, right? How to encode and decode, but we'll go over that next week maybe. Questions so far? All right, great. So now that we've done that, then we basically can use the model to predict logits. Right, so we use the NLI model with the data X, right? So, that's the model, the data is in X, and basically it's gonna use that. PyTorch, allows you to set the device that you're using. So you could say, if your model is in the GPU, you put your data in the GPU so it runs faster. In this case, I'm using CPU. I think I specified at the top somewhere. And so, but it doesn't matter because we're doing inference. Then we can print the logits. And as you can see, it basically provides, a standard logits procedure for, it's not softmax, if you notice, but it provides, probabilities of which one would be the most likely class. Okay, it may not be the best, but this is kind of an approach that you can also follow. Does this make sense, guys? Any questions on this one? All right, so yeah, so I'll just finish up. I thought I had a sentiment analysis one here, but maybe I don't. But let's just finish these out. Let's see. Let's do another one. So that one, which one was that? Do you guys remember? Was that entailment? Yeah. All right, great. So Roberta, I think we covered. And like I said, Roberta is just very similar to BERT. Yeah, so it's doing the cat is so sad. And yeah, fill in the mask or fill in the blank or masking. Okay. Notice that, which is hilarious to me. The mask here has greater than symbols instead of square brackets because Meta cannot use the square brackets that Google used. All right, so these kinds of things are really funny. All right, so anyway, I think they do it on purpose actually. All right, so let's now look at a few more here. So benchmark GPU, CPU, I think this is some code for you to like benchmark. So if you're curious about performance and things like that of your devices, Transformers does provide some functions for that. I don't have a GPU here, so I can't demo it, but later on we might come back to this to get a feel for it, or you might play when, say you have a GPU at home and you also use the Scholar GPU. I believe they have V100s there, so they have better GPUs, although not that many. And so you can try those out. So you can use code like this for benchmarking. Let's look at metrics and data sets. There's no transformer here or no model. Instead, I just want to show you guys some of the metrics. And like I said, I'll give you a paper. Remember that in this class, this is more of a high level, grad level class. So I will be giving you some papers for you guys to read. Not that many, but there's certainly some key papers in this. Like I've already posted Tavaswani one. Start reading through it, just for your own information. But anyway, so let's take a look at these metrics and data sets. So yeah, so we may need to install data sets. I can't remember if I did that. That's a good library to always have. So I'll add it in there just in case you need to install it if I haven't done so already, or you can install it if you're following along. All right, so from data sets, I want to list basically the data sets that are available here and also the metrics. Okay, so it doesn't have it. Let's go ahead. That's taking a while. Okay, I think, all right, I finished. Check to see that there are no errors, so everything looks good. Okay, so I'm going to comment this out. Okay, I'm going to hit run here. All right, so now we're going to bring in data sets and all metrics. All right, so it finished. So we can take a look at what's available. So we can basically list them out, get a feel for them. Okay. And then after that, we want to print out the number. All right, so if we run this one, we can see, according to this, there are like 97,000 data sets in there and 210 metrics. So these, as I said, these are the advanced metrics that if you decided, for instance, that you're going to use a BERT for your research, and your research is in language translation or summarization, when you write your research paper or publication, people that review it will say, okay, this is a summarization with LLMs. They're looking for a specific metric. Okay. They'll need to see that metric and to be able to compare it to what other people have done in the literature. Make sense? All right, so I've worked specifically like with language translation, and I use the BLEU score, the BLEU score. So that's a specific one for translation, but there's other ones. One famous one is GLUE. And like I said, all of this will become clearer in that paper I will post because it has the descriptions of what metric is good for what task. Okay, and this is really important as you say you've created a new model that's better at summarization. Well, don't invent a metric. You have to use kind of a metric that they use in competition. Remember that in 520 we did this, I think, competitions. Machine learning is competition, right? So you got to go in to these metrics. So here we can look at it. NLTK also provides good metrics. I've seen people use NLTK for metrics. This one has metrics. All right, so let's look at. Notice that when I ran this initially, this had 133 metrics. I probably ran this like a year ago or something, and now there's 210. So it's also growing. Okay, so let's go ahead and list out just 50 of the data sets. You can list out more if you would like. All right, so there's a lot of data sets in there. BBC, Bible, something. So there's definitely a lot of data sets in there that you could use for your models, etc. I will give you, and we'll talk about the mini project during the second half of today. You will need your own data set for that. So maybe you'll get it from here, or you can get it just anywhere online. Okay, but I'll describe what that's going to be about. All right. Any questions so far, guys? All right, I only printed 50 of these. You can certainly know that there's data in there. The metrics then. So this for the metrics, we can print all of them, basically. Okay. For metrics. This actually is going to be an important paper, probably one of the most important, to be honest. So I can give you the Vaswani and ask you to read it. I'll explain it in class and everything. But at the end of the day, you're probably using a HuggingFace model. But understanding the metrics is also a challenge, just like getting the data and converting it to the correct format is a challenge. Okay, so these are the important things. So if you look here, it's got something called the BERT score. And these are very interesting, where you use a BERT and the BERT actually gives the prediction is a score. So those are called a BERT score. All right, I'll show you an example of that also during the second half today. There's the BLEU, there's the BLEU score that I was talking about. So that's for translation. BERT, that's also, I believe, for translation, although I'm not sure, can't remember. But there's a Comet, that's one that I know is in that paper. There's the confusion matrix. So precision is there, makes sense. R squared, so they do have the traditional ones. I mean, there's lots of versions of BERT scores also. So you can see for, maybe tweaks somehow here and there. I know that there's a sentiment BERT. So basically, what is a sentiment BERT? It would be a BERT that takes in text, right, as a prompt, and it says a rating of positive or negative. How is this positive or negative text? Well, it makes sense to do this because one thing about transformers, GPTs, etc., BERTs, is that not only do they generate text, right, but you give them text. So in a sense, you can say that they can read and write text. So sometimes we just want them to read our text and give us a score. And sometimes we give them text and we want them to generate text. Usually you don't give them just a score to produce text. That kind of wouldn't make much sense, right? But we can leverage transformers to read our stuff. You know, they can read and give us their opinion, if you will, right? Or they can generate more text, like with the example of question answering. Got it? Any questions about that? All right, great. So these, as I said, I'm just listing out here some of the metrics that are available. I don't, for what we're, so yeah, so for the mini project, it actually would make sense for you guys to have a score and be able to show, okay, this is what I did and here's my score, right? The example I'll show you today during the second half, I don't have a score, actually. So I'll just show you some outputs and you can tell me what you think. So it's a qualitative analysis is what I have in my example. But really, if I was in a competition, that wouldn't fly, right? You'd have to have a score, okay? Because you have to look at all the sentences. You can't be subjective is what I mean, right? So that's what the scores are for. All right. Let's go over here. All right, so that's basically this example. So that's finished. Okay, so we did metrics. As I said, if you want to benchmark your GPU, CPU, etc., you can use this script. We've looked at this. Let's look at this one. Maybe this is the sentiment analysis one. I'm pretty sure I saw one. Yeah, here it is. All right, so let's do this sentiment analysis. This is a classic example in natural language processing. People have been doing this for a long time. Okay, oops. Nope. All right, there we go. So again, I know I've imported this pipeline, but I'm just clearing it out. So this one's super easy. Basically, it's like a default parameters, if you will. An example of default parameters of the pipeline that it really has, a model already associated with it for sentiment analysis. And so you give it some text. And it downloaded something by default. There it is. It's downloading it. Bless you. So it seems to be a BERT based on case fine-tune English, right? That's what I would say. Okay. And it says it's positive. You see that? So then said that one was positive. We can try another one. What's a negative sentence? We hate you. Okay. Negative, right? So what's something that's more complex than that? Let's think of a sentence that that's a good one. I like that. Okay. My cat kind of likes you. Just like that. Oh, I'm sorry. Okay. All right, so run it. Positive. My cat kind of likes you. What do you guys think? Is that correct or not? Or no?
I mean, that's not.
So then if that's the statement, then they like you for sure. Okay. Yeah. I don't know. So a neutral one, what about a neutral one, a difficult one? You're what? I'm going to the store. Okay. I'm going to the store. The store, sorry, store. Yeah. Store. Okay, so let's try it. Negative. Okay. So it may not have a neutral, possibly. Let's try just just one word maybe. What would be one word that has absolutely no emotional content? Blue? No, that might have. Car. Bacon?
Yeah.
That's positive. I'm, weather. Okay. The weather. 89. So it went down a little bit, right? They were all 99. So the weather. Let's try one last one. The weather. All right. So the weather. No, actually let's try the. Let's see what happens with the. So this has a bias towards positive for sure, right? So the model just likes when it doesn't know, it's just positive. All right. So anyway, that's the nice thing about these models. They're interesting sometimes. You never know what they're going to say and do. And, that's why people find them so fascinating, because they have like almost a way of thinking, right? Although they're not thinking properly, probably. All right. Okay, so yeah, so we did this example. We have 1 minute left, and then we take a break. Let's see, which one did I have left? So I just did this one, zero shot classifier. All right, I'll cover the zero shot classifier when we come back, and then also we'll get into the mini project and the homework assignment. Okay, so let's take a 10-minute break. So it's 6:20 until 6:30. I'll stop this recording.